All right, let's get started here on number 2. I see that this is an arithmetic sequence because it is in the form of mx plus b. And so what I'm going to do here is I'm going to use my sum formula, which is n over 2, the number of numbers divided by 2, and then times the first number plus the last number. So I do need to get that first number and last number. I actually already know that I have 20 terms. Because if I'm starting at the first term, then the last term, the 20th term, that would make 20 terms. So I do need a sub 1 here, so 10 times 1 minus 13, and so that's going to be negative 3, so I'll plug that in there for a sub 1. And then a sub 20, the last number in the sequence here, will be 10 times 20 minus 13, so 200 minus 13 is 187. So I'll add that right there. So I will just go ahead and divide these. That's going to give me 10, and then I'll add those together, and that's going to be 184. And so 10 times 184 is just going to be 1840 for the sum of that sequence. All right, next up here, number 4. So for this one, once again, I want to use that sum formula. So n over 2 times the first number plus the last number, since this is, again, an arithmetic sequence in that mx plus b form. Now, the number of numbers on this one, whenever you're not starting at 1, the trick I always use is top minus bottom plus 1, because there's a kind of an extra number than you would have thought there. So that's going to come out to 10 for my n value. And then I'm going to need my first number, which my first number is actually not a sub 1 this time, since we're starting at 5. I'm going to just find a sub 5 and a sub 14 for the one up top, just the first number that we're actually adding up. So 2 times 5 plus 4 is going to give me 14. And then 2 times 14 plus 4. Oops. No parentheses there. So that's going to give me 28 plus 4, so that's going to give me 32. So I'm just going to go ahead and I can divide these. That'll give me 5 times 46. So if I multiply that by 5, that'll be 230. All right, next up here, we do have another summation. I do see that it is arithmetic here because it's plus 6. And plus 6, and that's like the pattern there, consistent adding or subtracting. So I can use my sum formula here, and I know it's a sum because it's all adding there, and that's going to be n over 2 times the first number plus the last number. So it looks like I already have some of that information. I do know that n is 11, so I can plug that in right now. I know the first number is 29, so I can plug that in, but I don't really know the last number here. So what I need to do is I need to write a formula, a sub n equals, and I know the common difference is 6, so I'm going to say 6n. I'm going to say plus 23 here, kind of thinking about what would a sub 0 be. And so now I need to know the 11th term, since that's the last term in this case. So that's 66 plus 23. That's going to be 89. Okay, so now we'll just evaluate this. I'm going to go ahead and leave this as a fraction for now, because I think these will add to an even number. So it's going to be an 8 and 118. And so now I'm going to reduce that by 2. And that'll be 11 times 59. And so you can type this on the calculator. I have my multiplying 11s trick here. So that's going to be a 9, this will be a 4, and then this will be a 6, so 649. Our next one here, the instructions were still to find the sum of the series, so we're still dealing with our sum formula here. I know it's arithmetic because they do tell me the common difference, so I'm going to use n over 2 times the first number plus the last number. So kind of, once again, I have some information here. I know that the n is 14, that we're adding up 14 numbers. And then the first one is 13, but I don't really know the last one. So once again, I have to write my formula here. So I'm going to say 3n plus, and then I got to figure out a sub 0. So if you kind of think about this like a sub 1 is 13, that means that a sub 2 would be 16, since the common difference is 3. And so that means a sub 0 would be 10. So that works out as 10. So now I'll find a sub 14. So now we got to plug in 14 over here. And 3 times 14 is 42 plus 10, and that's going to be 52. All right, great. So we can go ahead and reduce this and make that 7, and then in here we'll add these to get 65. So 7 times 65, 35, 42, 45, so 455. All right, next up, these still ask us to evaluate the series. However, I see that this one is not mx plus b, and so that means that our usual sum formula will not work on this problem. So what we're going to do instead is we're just going to plug everything in. So 4 times 1 squared and plus 1, and I'm just going to keep doing that all the way down, and I'm just going to have to add up the results. There's really no shortcut here. But there's not that many terms here, so it won't be too bad. So this is 4 times 4 is 16, so that'll be 17 for a sub 2. A sub 3 is 4 times 3 squared plus 1. So 9 times 4 is 36 plus 1, 37. A sub 4, 4 times 3 squared plus 1. So 16 times 4. And this is a calculator question, so I'm going to switch over to my calculator here. Oh, but this should be a 4. And so that'll be 64 plus 1 is 65. And then a sub 5, 4 times 5 squared plus 1, so that's 101. And now we'll just add all that up. So 5 plus 17 plus 37 plus 65 plus 101. And that's going to give us a total of 225. All right, next up here, number 12. So this one I can see is a recursive sequence because of that a sub n minus 1. I know that refers to the previous term. So I know that if I want a sub 2, I'm going to do the square root of the previous term, which is 81. So that's going to be 9. And then a sub 3, I'm going to do the square root of the previous term, which is now 9. So that's going to turn into 3. And then a sub 4 is going to be the square root of the previous term, which is 3, which is just rad 3. So my sequence would go 81, 9, 3, and then rad 3. All right, next up here, number 14. So for this one, this is still recursive. And I kind of know that because of, once again, this relationship that here I have actually, I would think of this as the next term. And then this one is really kind of talking about the current term. But either way you think about it, the one out front is one ahead. So if this is a sub 2, this is going to be a sub 1. And then each time I'm going to add 2. So in this case, since a sub 1 is negative 36, I can just put that there and say this is negative 34. So then a sub 3 is going to be the previous term a sub 2 plus 2. So once again then, I can just, cross that out. I'm going to cross this out and actually put negative 34 there. So that's going to be negative 32. And you can kind of just take out the pattern now in your head. So just follow it along, just adding 2 every time. So the next one would be negative 30. There you go. All right, next up here, this one's kind of a mixture of an explicit and a recursive. This one is actually kind of the explicit piece, and then this part is the recursive piece. But what I notice here is that these two are always going to match, so whatever's up there is going to be in the subscript. So if I want a sub 2, it's going to be 1 plus 1 times a sub 1. So you can see here, as I'm doing it right now, the n is 1, and so both of those are 1. And then this one is now 2. So I can go ahead and actually, I need to plug this in now. So instead of this, I'm going to multiply by 2, since that's what a1 is. And so that's 2 times 2, which is 4. So now when I'm finding a sub 3, now this turns into a 2, and this turns into a 2 as well. Because once again, I just need those n's to match there. And now I'm going to plug in a sub 2, and I'm going to plug it in right there as a 4, which is what I got for a sub 2. So this is, let's see, 3 times 4, which is 12. And so then next up, I'm going to do a sub 4. And so when I do a sub 4, this now drops down to a 3, and this one has a sub 3. And the plus 1 is still there. And once again, just making sure that those ends match. And now I'm going to take this 12 from the previous term, a sub 3, and I'm going to plug it in right there. So this is 4 times 12. Trying to make sure I get this right, is 48. So those will be my first 4 terms, 2, which is the given, 4, 12, and 48. All right, here's we have to determine if these are arithmetic, so they should have a constant adding or subtracting. So you see the pattern here looks like a plus 9, plus 9, plus 9, and so I'm going to say yes, that is arithmetic. And I'm also going to find my formula here, so I can find, and that is the explicit formula. So I get 9n plus, and then a sub 0, remember, goes back there, which is the term in front of the first term, which is actually, what's that going to be, 26. All right, so now that's my explicit formula, but now I can use that to find a sub 40. So 9 times 40 plus 26. So for this, I can just do 9 times 4, which is 36, and throw a 0 at the end. And so that's going to give me 386. All right, so same idea here, but I got some fractions, so I'm going to see if it's consistent adding. So this looks like minus 4 over 3. It could be adding or subtracting, actually. And this is also a negative 4 over 3 because we do have that common denominator. And if I kind of think of this one as, what would I want to think of that one as? Let's see, let's just get a common denominator here. So let's call it negative 12 over 3. Then I can clearly see that the pattern continues to do that minus 4 over 3. So kind of better on these ones when you're examining that is to get that common denominator just so you can see that consistent pattern. So now I got a sub n equals, and that is going to be negative 4 over 3n. That's my common difference. And then just to go backwards here, I would have to add 4 over 3. So to 0, that's pretty easy. It's just positive 4 over 3. And that's my formula. So then for a sub 23, I'm going to do negative 4 over 3 times 23 over 1 plus 4 over 3. I can't cancel anything out, so I just have to do 23 times 4. So that'll be negative 92 over 3 plus 4 over 3. And this will add up to negative 88 over 3. So that'll be our 23rd term there. All right, next up again here, they're asking us if it's arithmetic. So this one I see it's a minus 100 pattern. So that looks like it is arithmetic there. And then if it is, find the recursive formula. So recursive formula, I always build it as a sub n equals a sub n minus 1. So it's saying to get the next term, I take the previous term, and then I just describe the pattern. So this pattern is minus 100 pattern. Now also for the recursive formula, we need the given. So I'm going to say a sub 1 is negative 20. All right, next up here, they want us to find the explicit formula and also another term, but I'll find the explicit formula first. So the explicit formula is really just the mx plus b1, and we know that the common difference is really the slope. So I'm going to say a sub n equals 10n plus a sub 0, which is what we use instead of b. You can call it b, honestly, if you want to. And so what I'm going to do to find that b, or that a sub 0, is to plug in this. So the 368 goes out front, and the 40 goes in for n. So this is going to be 400 plus a sub 0. That'll be 368. So I'll subtract the 400 over. And so this will be a negative 32 equals a sub 0. And so that's it. So we already have our explicit formula then. So it's a sub n equals 10n minus 32. And so then if you plug in 32, that'll be 320 minus 32. So that will be 288. All right, next up here, we want to find the explicit formula again. So this is once again the mx plus b, and this is really going to help me here to remember that m is really the slope here. So I'm going to think of these as 2 points, 14 comma 23, and then 34 comma 103. So I'm going to do y2 minus y1, just subtract the y values on top. x2 minus x1 on bottom. So that's 34 minus 14, okay, so that's 80 over 20, so that's 4. So I can say a sub n equals 4n plus a sub 0, and now I need to find a sub 0 by plugging in either one of these points. I'll go ahead and use this one, so 23 equals 4 times 14 plus a sub 0. 4 times 14, what is that? 56. So I'm just going to subtract 56 from both sides, and that'll cancel that out. And I get a sub 0 as negative 33. All right, so now I can write my formula here. A sub n equals 4n minus 33. And I'll go ahead and plug in 22 now. 4 times 22 minus 33. That's 88 minus 33, so that'll be 55. All right, next up here, number 28 says the purchase value of an office copier is $12,500, and that says year 0. So right off the bat, that kind of is giving me a hint there that this is a sub 0 is going to be $12,500. And it says its annual depreciation is $1,875. So to me, that's saying the common difference is negative $1,875, because it's saying every year it's worth that much less than it was the year before. So that's going to be how it's changing over time. So we want to write an explicit formula for this. So I'm going to say a sub n equals negative 1875n plus 12,500. It then asked us, well, that's kind of my first answer there. It asked us what's the value after 6 years. So I'm just going to plug in a 6. And that comes out to, and I'm just going to use my calculator for this since it's a calculator question. Type it all in, and it is $1,250, so $1,250. So it's definitely decreased in value a lot there. And so then it says, when will, the last question, well, when will it become obsolete? So that's like really worthless. And so that's going to be, I'm going to plug that in for a sub n. So that's the value of it is 0. When will this happen? So I'm going to add the 1875n over to the other side. I'm going to divide by 1875. I'll use our calculator for that. And that is 6.67 years. And so it's going to be somewhere during the 6th year, in between the 6th and the 7th year, it's going to be worth 0, according to this formula. All right, next up here, it says an architect designs a theater with 15 seats in the first row. So that's kind of telling me a sub 1, since it's a first row, is 15. And then we have 18, and then 21, and so on. And he wants the total to be 870. So use my sum formula here. And what we're going to do is we're going to say n over 2 times a sub 1 plus a sub n, so the first number plus the last number. I don't know what n is. I do know the first number is 15, but I don't know the last number either. So what happens in this case is I actually just write a formula for this. And so my formula is going to be a sub n equals, looks like 3n, and then a sub 0 would be 12, so plus 12. And I'm just going to plug that formula in for a sub n. And I do this so now I just have all my variables in terms of n. And then next up what I can do is I can actually plug in the 870 in for the sum, since that's what they want it to be. And next thing I'd like to do is I'd like to multiply everything by 2 on both sides, so I'll just cancel out that fraction. So this one becomes, actually it'll become 1740 equals n times, and I'm going to combine these to make 3n plus what is that? 27. So I'm going to subtract this 1740 over, because I see that when I distribute this in, this is going to become a quadratic. So I see 0 equals 3n squared plus 27n minus 1740. All right, next thing I notice here is that these are actually all divisible by 3, so I can take out a GCF here. So make that 9n, and then minus 1740 divided by 3. $580. So now I just need to factor this inside part here. So I'm going to think of two numbers that multiply to negative 580 and add to positive 9. So if I think about what multiplies to make 580, I got 10 and 58, so that's not going to work. I can do 20 and then half of that, which would be 29. So that is going to work if I do a positive 29 and a negative 20. And so I can split that up and set that equal to 0 and get n equals 20, and then set this one equal to 0 as well and get n equals negative 29. However, negative answers don't make sense for n since it's a number of numbers, so I'm going to say my answer to that one is 20.